Hello everyone, it's Mr. Scott again, and we're here for another maths video, this time on experimental probability. You can see, again, I'm using my Cornell notes, alright? As long as you're making some notes yourself and recording things, you should be fine. But what I've got here is some self-quizzing opportunities. I write down a question, I've got this covered up. Can I say what experimental probability actually means? Then have a look, see what it is. Okay, so what is it? Well, if I was doing something like rolling a die, then I can say there are 6 equal chances there, 1, 2, 3, 4, 5, 6. So the probability of rolling a 4, let's say, is 1 chance out of 6, 1/6. But you'll see with the ones we got down here, cars that go past my house, they're different colours. I can't calculate that probability. I don't know how many blue cars there are. I don't know how many cars there are altogether. In those circumstances, what I do is I perform an experiment. Okay, so I count how many cars of each different colour come past, and I use the fraction of the trials, the number of goes, so in this case the number of cars that are what I want, in this case blue, and I use that fraction as an estimate of the probability. Okay, it'll make more sense when we look at the example in more detail. All right, another question here, what is relative frequency? Basically it's the same thing. Okay, what fraction of the trials were successful? All right, so these two terms, they mean the same thing. They might use either in the exam. All right, let's see it in action, because everything makes more sense then, doesn't it? So here's the worked example. I counted the cars that went past my house. Yeah, we're all a bit bored at the moment, aren't we? All right, I counted the number of cars. I counted what colour, what fraction, no, I counted how many different colours there were that came past. There were 4 blue cars, there were 5 red cars, and so on. And my estimated experimental probability is the same as my relative frequency, and that is the number of successful trials, I've only just got enough space here, over the total number of trials. So in this case, I want blue cars. So how many blue cars came past my house? There were 4. Over the total number of trials, how many cars came past my house? Well, 4, add 5 is 9, add another 9 is 18, add 2 is 20. I'm counting them in the way that makes it easier for me to add them up. So 4/20. That is my experimental probability. Now, it will probably be easier for me to use that if I simplify it. I can see that there is a common factor of 4 and 20, a number that goes into both, and that is 4. So divide the 4 by 4 and I get 1, divide the 20 by 4 and I get 5. So the relative frequency is 1/5. 1 car out of every 5 was blue, and I use that as my estimated experimental probability. Okay, your turn. From the same experiment, so you've got the same numbers of each colour, can you now estimate the experimental probability that the next car is red? Have a go, pause the video while you're doing it, and I'll see you in a minute or two. Right, so your estimated experimental probability is equal to your relative frequency. I'm not going to write relative frequency this time. So, number of successes, number of successful trials, got a little bit more space now, over the total number of trials. So, how many cars were read? 5 out of how many cars were there altogether? We already know that's 20. 5/20. That's your relative frequency. That's your experimental probability. It will simplify. Both these numbers divide by 5, cancels down to 1/4. You'd expect 1 out of every 4 cars to be read. Now, it'll probably turn out to be a little bit different from that, but it'll be something along those lines. All right, so how am I going to summarise this? Well, I'm just going to say again that experimental probability is equal to relative frequency and that's the fraction of successful trials. So the number of successes over the total number of trials. How many times did you carry out the experiment? Right, have a go at the questions on MathsWatch or on the PowerPoint, and I'll see you again soon. Bye.